Okay, next is we want to study about the chemistry of ester. Ester is one of the carboxylic acid derivative. So first we learn about the preparation of ester. Okay, and next we learn about the reaction of ester. Okay, first reaction of carboxylic anion with a primary alkyl halide. Okay, this one is carboxylate anion. Okay, react with alkyl halide. Primary alkyl halide. This is a primary alkyl halide undergo with SN2 reaction to produce ester. Okay, we want to prepare ester. Okay, number 2, Fischer Esterification. Please star for this slide. It's very important. Fischer Esterification for your test also have this topic. Okay, so there are 3 types: carboxylic acid with alcohol, acid chloride with alcohol, acid anhydride with alcohol. Okay, from carboxylic acid. Okay, from carboxylic acid react with alcohol to form ester by using H2SO4 as a catalyst. Okay, so here is the mechanism. Please star for this Fischer Esterification mechanism. Okay, mechanism. This one is carboxylic acid. Okay, lone pair, abstract this proton. Okay, it become this one product attached. O become positive. So this one nucleophile will attack this C double bond O, become ozonium ion. Okay, O become positive. Okay, so next is proton transfer step. Okay, look at here. Okay, loss of water. So intermediate become resonant, and lastly you form ester. So this one is mechanism for Fischer esterification. Is the most important part for the mechanism. Okay, for B is from acyl or acid chloride. Okay, so this one acyl chloride react with alcohol or phenol in pyridine to form ester. Okay, reaction with benzoyl chloride. Okay, benzoyl chloride is less reactive. Okay, simple acid chloride such as ethanoic chloride does not reactive with the phenol. Okay, phenol will convert to sodium pentoxide salt and then proceed to react with benzoyl chloride, so become ester. Here is the intermolecular esterification to form lactone. So please start for this slide. Okay, this one. Okay, to form lactone. Okay, lactone, the product is lactone. So this one is mechanism. This one OH lone pair. OH is very nucleophilic, so attack this one. C double bond O electrophilic to form a cyclize. Okay, so cyclize, and then this one eliminate step. Eliminate step means that lone pair move to this one by sigma bond to become double bond, C double bond O. So Cl will detach from this carbon. Okay, so this is for intermediate. We don't want this positive charge, so chloride ion abstract proton and electron move to the O, so O become lone pair, positive become lone pair, so side product is HCl. So this mechanism to form lactone is slightly easier compared to mechanism of this one. Okay, next is acid anhydride react with alcohol to form ester, and also side product carboxylic acid. Okay, so because all this to form ester from acid anhydride, from the acid chloride, and also from the carboxylic acid. Okay, this under Fischer esterification there are 3 types. Okay, all the derivative carboxylic acid, okay, react with alcohol to form ester. Okay, next reaction of ester. First, hydrolysis. We want to convert ester to carboxylic acid. Okay, so there are 2 conditions. First, in acid and basic condition. Okay, look at the acid condition, ester react with the water. In acidic condition, form carboxylic acid and also alcohol. But if the basic condition, if this ester react with water in basic condition, so the product is carboxylic salt. Okay, we don't want the carboxylic salt, so we need to produce an end product of carboxylic acid by adding HCl with the carboxylic salt to form carboxylic acid. Okay, so here is the mechanism. Okay, first step, protonation of the carbonyl group. Okay, it's a different from the nucleophilic. Okay, so first we want to protonate the carbonyl. Protonate carbonyl to activate the nucleophilic attack. Okay, so protonate means that this lone pair abstract this proton, so it's become O positive. Okay, because we want to activate carbonyl group for easily to nucleophilic attack. This one is very weak electrophilic, so we want to make a more electrophilic. Okay, which is this lone pair abstract proton. So C double bond OH is become more electrophilic, then nucleophilic can attack this carbonyl. Nucleophilic attack by water, so water react with water, because from this general equation using water, okay, lone pair from the water attack on this C, because this carbonyl is very more electrophilic, so the nucleophilic will attack on this carbon. Okay, so cleave this pi bond, so become OH. Or there are no positive charge because of pi bond is cleave and electron move to the O, so O become neutral. So this one, because there are two lone pair, so this lone pair from OR, so abstract this proton and electron move to this one. So step 3 is eliminate. Okay, this one from the step 2, O abstract proton from here, so H attach on O, so O become positive. Ni lone pair. Okay, this one is alcohol. There are two alcohol here. So eliminate occurs when pi bond form between C double bond O. Okay, in step 2 there are no carbonyl. Okay, the end product is no carbonyl. So next product we want to eliminate because we want to form pi bond between C and O. Regenerate. So keywords for step 3, regenerate. And then alcohol will expel once lone pair abstract this proton. Okay, so this one move to here and this one move to here, it's become alcohol. So CH2CH3 it's become alcohol. Okay, this one's become carboxylic acid and alcohol. This is a mechanism, okay, for the reaction of hydrolysis. So base hydrolysis, okay, this one is for base. Nucleophile attack by OH minus. It's different from the acidic. Acidic, we need to create C double bond O become more electrophilic, so nucleophile easy to attack. But for the basic condition, nucleophile OH minus, because OH minus is a strongest nucleophile, so this stronger nucleophile will attack on OH by OH ion, cleave attack on C and cleave this pi bond to form the intermediate alkoxide. Okay, alkoxide intermediate. And step 2, okay, we don't want this negative, so the next step is eliminate. We want to eliminate, okay, to form pi bond. Okay, to form pi bond here, then this electron will leave. Okay, so here become double bond carboxylic acid, so this one is alkoxide as a side product. So third one, okay, alkoxide ion, strong base. This is a strong base, so remove proton from here, remove from carboxylic acid to form alcohol. Okay, so this one becomes C double bond O minus. Okay, so this one is the base hydrolysis for sulfonification. Okay, to make a salt. Okay, salt is a very large structure, so we use a fatty acid. Okay, react with the strong sodium hydroxide to form salt in sodium salt and also glycerol. So next is aminolysis. We want to convert ester into amide. Okay, ester react with ammonia, react with primary and secondary to form amide. Okay, with alcohol. Next is reaction with Grignard reagent. Okay, we know that it undergoes nucleophilic acid substitution. Okay, this one ester react with 2 equivalent mole of Grignard. Okay, react with 2 equivalent mole of Grignard reagent. Okay, to form tertiary alcohol. For this one, the product is tertiary alcohol because here there are 2 mole of RMGX. So that's why you get the product in tertiary alcohol. Here is example. Okay, now is the mechanism, which is ketone is more reactive toward to Grignard reagent, and we react with a second molecule of Grignard reagent. That's why we're using a 2 mole of Grignard reagent. First, this one, okay, attack on C double bond O, so pi bond cleave, so it become alkoxide. Okay, this one is OR and MgX positive nearest to the negative charge on this one. So alkoxide. So next step, we want to eliminate to form a double bond here, and then leaving group OR as a leaving group. Okay, second one. Okay, once you get this ketone react with the Grignard reagent. So Grignard reagent attack this carbonyl. So this one eliminate cleave the pi bond to become O minus MgX positive. So there are 1, 2, 3 of substituent attached on C OH. That's why to form tertiary alcohol. In this mechanism, there are 2 times attack by the RMGX. First, RMGX attack on C to become ketone. Once you get ketone, again react with the RMGX to form salt, and lastly to form tertiary alcohol. Next is Transesterification. Okay, look at here, ester react with the large excess of alcohol, means that we're using excess of alcohol, more than 1 mole of alcohol to form ester and alcohol. So this one is mechanism in basic condition. Okay, first, nucleophilic attack by alkoxide. Nucleophilic attack by alkoxide is the same of the rule of nucleophilic mechanism. Okay, so pi bond will cleave, okay, to form this intermediate in O minus. This one attached on C. Once after attack, so this nucleophile attached on C. So leaving group removal, this one is step for elimination. It's mean elimination to form C double bond O. Okay, so OR will leave from this C double bond O. Okay, so this one for the acidic condition. In acidic condition, first half, acid-catalyzed addition of nucleophile. First step, protonation of the carbonyl. Okay, it's different from this one because basic is very strong nucleophilic, but proton is very weak. So that's why we need to protonation of the carbonyl. Still basic in nucleophilic. Okay, first you need to protonate the carbonyl because we want to activate the carbonyl. So easy to nucleophile attack. After protonate, so it become more electrophilic, then nucleophile can attack on this C double bond OH. Okay, step 3, deprotonation. Deprotonate by using the same of reagent. Okay, this lone pair from the reagent, abstract this proton. Okay, and it become OR, and then this one as a side product. Second half, okay, acid-catalyzed elimination. So from above here product, so protonate of the leaving group, you want to leave this leaving group. Okay, so step 2, eliminate of the leaving group here, and last one is deprotonation. Deprotonate to form the end product of ester. Next is reduction. Okay, reduction of ester to form alcohol. Okay, reduction with lithium aluminum hydride to yield primary alcohol. This is a very strong reducing agent. Okay, so this one is a mechanism, reduction of ester. So reduction of the ester give the primary alcohol. Okay, this one. Okay, lastly you will get the primary alcohol. Okay, next is reduction of ester into aldehyde by using debal. This is a mild reducing agent. Okay, you get the aldehyde and alcohol. So this one is example and some of exercise from the reaction and preparation of ester.